Picture the prettiest shell you have ever seen on a beach. Smooth, polished, painted with patterns that look hand-drawn, like someone took a fine brush to it. The kind of shell you would pick up without thinking and slip into your pocket to take home. Now picture that same shell firing a harpoon into your hand. That is not a scene from a horror movie. That is a real animal. And it lives in the warm, shallow water where people swim and wade every single day. It is called the cone snail. It moves slower than almost anything alive. It has no claws, no teeth you would recognize, no speed at all. And yet some of these snails carry a weapon so fast, so precise, and so loaded with venom that there is no antidote for it anywhere on Earth. People have died holding one. They thought they had found a treasure in the sand. What they had actually picked up was one of the most advanced hunters in the entire ocean. And the strangest part is how it kills. Because this animal does not bite, it shoots. And it has been perfecting this trick for tens of millions of years, long before anyone gave it a name. Let me show you what a cone snail really is. Start with the shell, because the shell is the first trick. Cone snails get their name from their shape, a smooth cone wrapped in color. Collectors have prized these shells for centuries. Some rare ones once changed hands for serious money, back when people believed a beautiful shell was just a beautiful shell and nothing more. There are more than 700 known species of cone snail. They live in warm oceans all around the world, coral reefs, sand flats, tide pools, the exact places we splash into on vacation without a second thought. Here's the first thing that should bother you. That gorgeous pattern is not there for us. Underwater, those colors and swirls help the snail melt into the coral and the sand. The beauty is camouflage. It is bait for the eye. We look at a cone shell and we see art. A small fish swimming past sees nothing at all. Nothing, that is, until it is already too late. And these animals are old. Cone snails have been hunting the oceans for tens of millions of years, polishing the same basic strategy the entire time. They never got faster. They never grew into giants. Instead, they got better at chemistry than almost any other creature on the planet. That choice is the whole story. Here is something most people never learn about cone snails. Not all of them hunt the same way, and not all of them are dangerous to you. Scientists sort them into 3 rough groups by what they eat. Most cone snails are worm hunters. They cruise the sand and the reef looking for marine worms, and their venom is tuned for that small, slow prey. A second group hunts other snails and shellfish, poisoning their way into a neighbor's shell. And then there's the third group, the smallest and the most extreme, the fish hunters. Catching a fish is a completely different problem from catching a worm. A worm cannot dart away in a heartbeat. A fish can. To bring down something that quick, the fish-hunting cone snails had to evolve the fastest, strongest, most complex venom in the whole family. That is exactly why the species that worry doctors, like the geography cone, are almost always fish hunters. They needed a better weapon, because their prey could escape. The worm eaters never did. So, when you hear that a cone snail can kill a person, understand what we are really talking about. A specific, elite branch of the family. The chemists, the few that learned how to drop an animal with a backbone. So how does something this slow catch a fish that can swim circles around it? Here is where the cone snail stops being a pretty shell and starts being a machine. Hidden inside its body is a long, flexible tube called a proboscis. Think of it like a soft snorkel the snail can stretch out, bend, and aim. At the very tip of that tube sits the weapon. Most snails have a kind of ribbon in the mouth, covered in tiny teeth, used for scraping algae off rocks. The cone snail took one of those teeth and rebuilt it into a harpoon. It is hollow, like a needle. It is barbed at the end, like a fishhook, so it does not pull back out. And it is filled with venom from a long gland buried deep inside the animal. The harpoon is single-use. The snail grows them in a row inside its body, like spare arrows kept in a quiver. When it needs one, it loads a fresh tooth into the tip of the proboscis, charges it with venom, and waits. It does not chase. It cannot chase. So it hides, it aims, and it lets dinner come to it. Patience is the entire plan. Here is where it gets strange. When a fish drifts close enough, the cone snail fires. The harpoon shoots out on the end of that long tube and stabs the fish in a fraction of a second. Far too fast for the fish to react and flee. The venom goes in instantly. The barb holds the prey in place like a hooked fish on a line. The slowest animal on the reef has just landed a strike the eye can barely follow. For many cone snails, that is the hunt. One shot, one fish. But the most dangerous species have something even colder. And it gets stranger. Take the geography cone, one of the deadliest of them all. Instead of simply spearing a single fish, it does something that sounds almost impossible for a snail. It opens its mouth into a huge balloon, a kind of living net made from its own stretched body. Then it releases a cloud of venom into the water around it. Scientists who study this call it a sedative cloud. The chemicals drift over the gills of nearby fish, and the fish go quiet, calm, sluggish, almost sleepy. The snail then engulfs them, sometimes more than one at a time, swallowing them whole into that wide open mouth before harpooning each one from the inside. Read that back slowly. A snail gasses the water. It lulls a small group of fish into a trance. It scoops them up like a net, and it finishes them off from inside its own mouth. That is one of the most sophisticated ambushes in the entire sea, and it belongs to an animal with no real brain and no legs at all. So what is inside that venom that can drop a fish in seconds? For a long time, scientists understood it mainly as a paralyzer. The venom shuts down nerves, freezes muscles, and stops the fish from swimming away. That alone would be impressive enough. But in 2015, a team studying the geography cone found something nobody expected. The venom contained insulin. Insulin is the hormone your own body uses to control blood sugar. It is the same chemical a person with diabetes injects every day to stay alive. And this snail had evolved its own version of it. Not a copy of snail insulin, a copy of fish insulin, tuned to the prey it hunts. When the snail releases this into the water, the nearby fish take it in and their blood sugar crashes. They drop into what is basically hypoglycemic shock. Their bodies suddenly run out of fuel. They turn slow and confused and easy to swallow. When I first read that, I had to read it twice. This snail is not just poisoning its prey. It is weaponizing one of the most basic chemicals of life, the molecule that keeps animals running, and using it as a knockout drug. At the time, no other animal on Earth was known to do this. The cone snail figured it out long before our scientists even thought to look. Now, you might be wondering why an animal this deadly is not ruling the whole ocean. Here is the cost, and it is a real one. The cone snail is slow, painfully slow. It cannot run anything down. Its whole life hangs on the ambush, on patience, on getting one shot right. Each harpoon is a single-use weapon that takes energy to build and to reload. Miss the strike, and dinner simply swims off. Out of its shell, hunting, the snail is soft and exposed. It traded speed for chemistry, muscle for venom. That trade only pays off if it stays hidden and picks the perfect moment. It is a sniper, not a soldier. If this is the kind of story you came for, the kind where the small and overlooked thing turns out to be far more dangerous than the big and obvious one, take a second and subscribe. Every week we go into worlds almost no one looks at twice. Because the reef is full of animals exactly like this. Quiet, beautiful, patient, and far more advanced than they have any right to be. Now here is the twist that flips the whole story. That venom, the thing that makes the cone snail so frightening, may also be one of the richest pharmacies in all of nature. The cone snail's venom is not a single poison. It is a cocktail of small proteins called conotoxins. A single species can produce well over 100 different ones. With more than 700 species out there, scientists estimate that cone snails together carry an arsenal in the hundreds of thousands of unique compounds. And we have studied only a tiny sliver of it. What makes conotoxins so valuable is their precision. Each one is built to hit one exact target in the nervous system and nothing else. That kind of accuracy is precisely what drug makers spend fortunes chasing. A molecule that does one job, cleanly, with no collateral damage. Why does that precision matter so much? Your nerves and your muscles run on tiny gates called ion channels. They open and close to send signals, to feel, to move, to keep your heart beating in rhythm. Most drugs are clumsy by comparison. They flood the whole body and bump into many targets at once, and that is where side effects come from. A conotoxin is the opposite. The snail spent millions of years sharpening each one to jam a single specific gate and leave everything else untouched. That is a level of control our own laboratories still struggle to match. In a way, every conotoxin is a finished experiment the snail already ran, and we are just reading the results. One of them already became a real medicine. It came from a different cone snail, one nicknamed the magician cone, and it was approved for human use back in 2004. It is a painkiller, and not a gentle one. It is used for severe, chronic pain that does not respond to anything else, including pain so brutal that morphine fails to touch it. Think about that. A toxin built to freeze a fish became a drug built to free a human being from agony. And researchers are still combing through that vast chemical arsenal, one peptide at a time, hunting for the next breakthrough hiding inside a snail. To do that, scientists have to collect the venom, and even that is a small adventure. In the lab, researchers coax a snail into striking a target, sometimes a thin membrane stretched over a tube, and capture the venom it injects. They study each tooth, each compound, each tiny dose. The same weapon that makes this animal feared is now studied under microscopes around the world, because every harpoon it fires is a chemistry lesson we are still trying to read. So what does all of this mean for you, standing in warm, shallow water on some beach? It means be very careful what you pick up. The cone snail's harpoon can punch through a wetsuit glove and through human skin. Almost every sting happens the same way. A person spots the beautiful shell, picks it up, turns it over in their palm to admire it, and never realizes the animal inside is alive, awake, and aiming. It happens to the people you would expect and to people you would not. Divers reaching into a reef, children combing a tide pool at low water, fishermen sorting a catch and tossing the pretty shell from one hand to the other. The snail does not warn you. There is no hiss, no rattle, no flash of color that means danger. By the time you feel the sting, the harpoon has already fired and the venom is already in. And because the prick can feel small at first, some victims do not even take it seriously until the symptoms start to climb. Now, I want to be honest with you, because a lot of the internet is not. Cone snail deaths are rare, genuinely rare. Across roughly the last 300 years, only a few dozen human deaths have ever been linked to the most dangerous species, and even that number is uncertain and hard to confirm. You are very unlikely to die from a cone snail. I am not here to make you afraid of the ocean, but here's the part that keeps doctors uneasy. If the worst does happen, there is no antivenom. None exists anywhere in the world. The only treatment is to keep the victim breathing, sometimes on a machine, until the venom finally wears off on its own. Medicine cannot fight it directly. It can only buy time and hope. So the danger of the cone snail is not that it kills often. The danger is that when it does strike a person hard, all we can offer is patience of our own. And that brings us to the name. The geography cone carries a grim nickname, the cigarette snail. The legend goes that if one stings you, you have just about enough time left to smoke a single cigarette before it is over. It is a dark little piece of folklore, and like most folklore, it is an exaggeration. A serious sting does not finish in 5 minutes. It can unfold over hours, but the nickname stuck anyway, because it captures something true about how this animal makes us feel, helpless. The beauty pulled you in. The shell felt like a gift handed up from the sea floor, and the creature inside had a plan you never saw coming. For divers and shell collectors, that legend gets passed hand to hand as a warning. Look, but do not touch. The prettiest shell on the reef is the one most likely to be hiding a loaded weapon. People have carried these home as souvenirs, set them on a shelf, not realizing the snail was still alive inside, still holding its harpoon, still waiting for one last chance to use it. So let us go back to that beach, that perfect shell in the sand, smooth and painted and practically begging to be picked up. You know now what it might be. A slow animal with no claws and no speed, carrying a single-use harpoon. A cloud of sedative venom it can pour into the water. A copy of fish insulin built to crash a living body's blood sugar. and a chemical arsenal so deep that we are still mining it for new medicine decades after we found it. It cannot run. It cannot bite the way a shark bites. It does not need to. It outthought every fast thing on the reef using nothing but chemistry. That is the real lesson of the cone snail. In the ocean, the most dangerous animal is not always the biggest or the fastest. Sometimes it is the one that learned to be patient and got very, very good with poison. So here's my question for you, and I honestly want to know what you think. If a snail can weaponize insulin and stump our best chemists for decades, what else is hiding in plain sight out there on the reef, wearing a shell we would call beautiful? If this changed the way you see a simple seashell, subscribe. Every week, we go into worlds almost no one looks at twice. And the next time you are standing on a beach, and you spot that perfect cone-shaped shell lying in the sand, look at it, take a photo of it, and then leave it exactly where it is,